everyone. In this video, we are going to work on the quantifiers. Quantifiers means up to what extent the predicate is true over the range of elements. Means predicate कितने extent तक true है for the range of the elements. Now, what do you mean by predicate? Predicates are the statement that involves the variable. Let's take an example. Suppose we are taking x square is greater than 2. Now this is a statement that say that the square of x is greater than 2. अब ये statement कितने extent तक true है? Means for what value of x the statement is true. Whether this is true for every value of x or for some value of x. So when we are dealing such words like all, some, many, none, or few, that comes under the part of quantifiers. In this video, we are going to learn the two main quantification, that is the universal quantification and the existential quantification. Now, universal means when we are dealing with the entire domain, and when we are dealing with the few or maybe for some values of variable, then it comes under the part of existential quantification. Let's try to understand this with the help of example. Suppose we have the example, everyone is perfect. Now this example comes under what quantification? Right now we are saying that everyone is perfect, means we are dealing with the entire domain. So it comes under the part of universal. And in the next case, we have taken x square is greater than or equal to 0 for all real numbers. Again, we have discussed for the entire domain that all real numbers. So again, it is a part of universal quantification. In the next example is someone is perfect. It is not about the entire world. So it is saying maybe कोई एक ऐसा है जो perfect है. Someone is perfect. So it comes under the part of existential. So when we are dealing with the entire domain, it comes under the part of universal. And when we are working with a few or maybe for some, that is a part of existential quantification. Now we are moving towards the definition of universal quantification. Universal quantification. The universal quantification of statement Px means Px for all values of x in the domain. So when we are working with the all values of x, that comes under the part of universal. There is a proper notation for this one because we every time cannot write for every values of x in the domain. We can write in a shortcut way, that is a notation form. In this case, we can write for all x Px. This represents the universal quantification of Px. And we read it as for all x Px, or we can say that for every x Px. Now what does it mean? Like we have the statement, it say that let Qx be the statement x is less than 2. What is the truth value of the quantification for all x Qx where the domain consists of all real numbers? यहाँ पे हमने universal quantification use किया है because it is a for all x. We can read it as for all x from where? From set of real numbers. Now what is a Qx? Qx is a statement that is x is less than 2. Now is this statement is true means for every value of x from the set of real number that x is always less than 2? No. So every real number is not less than 2. So आपको क्या करना है? Simply you need to check what quantification is used, that is for all x. So it means we need to work with the entire domain. क्या entire domain में variable ये property follow कर रहा है means x is less than 2. So if no, so final answer in this case is false. So this statement is clearly false. Let's take one more example. What is the truth value of for all x Px where the Px statement is x square is less than 10 and the domain consists of positive integer not exceeding 4. Now domain में कौन से elements हैं? So domain consists of 1, 2, 3 and 4. As it is not exceeding 4, so we need to take 4 but not 5. And positive integer starts from 1, not from the 0. So we need to check, that is for all x px, whether the statement is true or false. Means for all x square is less than 10. Is this a true statement or false? Let's check it. When we take x is equal to 1, it is 1 square is 1, that is less than 10. Yes. What about 2? 2 square, that is equal to 4, less than 10. Yes. For the 3, 3 square, that is 9, is this is less than 10? Yes. 4 square, that is 60, is this is less than 10? No. This means this statement is clearly false because this is not applicable for every value of x. Moreover, rather than writing for all or for every in a universal quantification, we can also write all of x for each x, or we can write for given any value of x, or we can say that for arbitrary x. So these all expression comes under the part of universal quantification. Next is existential quantification. The existential quantification of Px is the proposition that states that there exists an element x in the domain such that Px, like in a universal quantification, we are dealing with for every value of x. Here we just need an element x from the domain such that Px is true. That come under the part of existential quantification. The notation for the existential quantification is this. This represents the existential quantifier. Let's understand what do you mean by this with the help of example. Suppose we have the statement x is greater than 3. We need to predict what is the truth value of this. Now what does it mean? It means whether there exists any value of x from the real number such that x is greater than 3. So we read as there exists an x from the set of real number such that x is greater than 3. Whether the statement is true? Yes. There exist many numbers, but we need at least one. So if we are getting at least one value of x from this domain for which the statement is true, we can say that its truth value is true. Let's take another example. What is the truth value of there exists x px, where px is a statement x square greater than 10 and the universal discourse consists of positive integer not exceeding 4. So again it gives the domain as x belongs to 1, 2, 3, 4. So we need to take all positive integers that is not exceeding 4, means we need to take 4 here. So from this domain, whether the statement is true for any value of x, let's check it. For 1, when we take x is equal to 1, is 1 is greater than 10? No. Is 2 square is greater than 10? No. 3 square is greater than 10? No. 4 square is greater than 10? Yes, because this is a 16 and 16 is greater than 10. It means yes, there exists a value of x from this domain such that x square is greater than 10. So it means the truth value of this statement is again true. As we have done in a universal quantification, there are many ways to represent for all x in multiple words, like for all x, for every x, for each value of x, for arbitrary x. Similarly, we can represent there exist x in many ways. That is, for some x, or maybe right for at least one value of x, or we can say that there is a x. So these all expression comes under the part of existential quantification. Let's take a look on this example. Let Qx be the statement. It states that x plus 1 is greater than 2x. Now the domain is consist of all integer. We need to predict what is the truth values of these statement. Now what do you mean by Q0? Here Qx is equal to x plus 1 greater than 2x. Q0 is 0 plus 1 greater than 2 of 0. Means 1 is greater than 0. This is the statement Q0. Now it get converted into the proposition. Initially it is a predicate. Now the statement is true or false. So the statement is clearly true. So its truth value is true. What about Q of negative 1? Replace x with negative 1. So this implies 0 is greater than minus 2. Yes. So its truth value is again true. Q1. So 1 plus 1 is greater than 2. Is the statement is true? No. So the statement is false. Now we are going to deal with the universal and the existential quantification over the statement. It says that whether there exists any integer such that x plus 1 is greater than 2x. क्या कोई ऐसा इंटीजर है जहां पे ये स्टेटमेंट ट्रू है? Yes. So you can take x is equal to 0. 0 के लिए valid है? Yes. It says that at least we need one integer. So if you are getting a one integer, it means the statement is true. What about this? For all x qx, क्या ये statement हर एक integer के लिए valid है? No. Why? Because it is not valid for x is equal to 1. When you take x is equal to 1, we are getting 2 is greater than 2. That is completely incorrect. It means the statement is false. Now what about the f part? It says that there exists x not of qx. तो पहले हम इसका not लिखेंगे. Not of this one is x plus 1 is less than equal to 2x. Here we have written greater than. Now less than equal to is the not of the statement. So now whether there exists any value of x such that x plus 1 is less than equal to 2x, तो किसी भी x के लिए क्या ये statement valid है? Means true है? Let's check it. You can put x is equal to 1. When you put x is equal to 1, this is 2 and this is again 2. तो valid है? It means the statement is true. What about the G part? For all x, negation of qx. Negation of qx is this. So x plus 1 less than equal to 2x. क्या ये statement हर एक x के लिए valid है? Let's check it. Whenever we have mathematical statement, we can simplify this. अगर आप इसको simplify करोगे, so we have 1 is less than equal to x. We can take this x on the right side, we get x. It says that ये statement सिर्फ valid है whenever x is greater than equal to 1. Otherwise valid नहीं है. It means 0 के लिए ये valid नहीं होगी. तो check कर लेते हैं. X is equal to 0, that is 1, less than equal to 0. So clearly invalid है. It means the statement is false as it is not true for every value of x as an integer. So this is how we need to check whether the statement is true or false under the given domain and using quantification. Now the main concept is when we are dealing with the universal quantification and existential quantification, how we are predicting whether the statement is true or false. Like when we are dealing with the domain element, suppose we have n elements x1, x2, xn. In a universal, when we write for all x, px, what does it mean? We are saying that the statement is true when it is true for x1 as well as true for x2 as well as true for xn. It means we are using a conjunction. So when we are dealing with the universal quantification, we are applying conjunction over the statement for each element of the domain. So if all the statements are true, we are saying the statement is true. If any one of them is false, it means we say for all x, px is false. In case of existential quantification, there exists px. It is same that when we say that if the statement is true for x1 or x2 or x3 or xn. So we are using disjunction in this case. So we say that there exists px is true when at least one of them is true. And if all are false, we say that the statement is false. Okay. In short, we can say that for all x, px is true when px is true for every value of x that is in a domain. And for all x, px is false when it is false, when there is an x for which px is false. अगर कोई एक भी x मिल जाए जिसके लिए px statement is false, we can say that the entire statement is false. On the other hand, there exists px is true when this is true, when we get there is an x for which px is true. तो अगर आपके पास कोई एक x मिले जहां पे ये स्टेटमेंट ट्रू है, we can say that statement overall is true. And there exists px is false when px is false for every value of x. So this is how we need to check when the statement is true or false and when there exists px is true or false. Now let's look how these quantifications are applied on the statement forms. Suppose we have the statement px that represents x can speak Russian. Qx is a statement that says that x knows the computer language C++. We need to express the statement in terms of px, qx, quantifiers and logical connectives. The domain for the quantifiers consists of all students at your school. The first statement is there is a student at your school who can speak Russian and knows C++. Right now we need to identify whether this is dealing with the universal or a existential. It says that there is a student. So it means it is not dealing with the all student at your school. So it means that is a part of existential quantification. We write there exists a student at your school by this form. What is the property of this X? That student can speak Russian and knows C++. Can speak Russian is represented by px. So we can write px and is represented by conjunction. Who knows C++ is represented by qx. So in predicate and quantifiers, we represent this line by this form. Let's take another example. There is a student at your school who can speak Russian but who doesn't know C++. Again, identify whether this is a part of universal or existential. Like it mentioned as there is a student. So there is a student means there exists X at your school who can speak Russian. It means PX, but is get converted into and, that is a conjunction, who doesn't know C++. So it means it is a negative of the sentence, not of QX. So this is how we represent this sentence in a predicate and quantifier form. Next is every student at your school either can speak Russian or knows C++. Now, when we say that every student, it means we are dealing with the entire domain. It means it comes under the part of universal quantification. So, every student at your school either speak Russian or knows C++. It means it is a part of disjunction or. So, we write PX or QX. So this is how we can write the statement in form of predicate, quantification and logical connectives. Now there is a precedence of the quantification. Remember that the quantification for all x there exists has highest precedence than all the logical operators from the propositional calculus. Like we have this case for all x px or qx. So in this case, first we will put the bracket over the quantification. It means it say that for all x px or qx. So the highest precedence is always given to the quantification, and then we can deal with the logical operator. So it means the first precedence is for all x there exist. Second is given to the negation. Third is given to the conjunction. Fourth is to the disjunction. And the fifth is for the conditional. And sixth for the biconditional. Also note that there are many ways to define the quantification, like there exist for all x, or maybe there are exactly two variables we need for which the statement is true, or maybe we need there are no more than 3x for which the statement is true. Similarly, we can define one more unique quantification that is called as uniqueness quantification. Now, what do you mean by this one? The uniqueness quantification of Px is a proposition which says that there exists a unique value of x in the domain such that Px statement is true. And its notation is similar to there exist, but we will put this sign or we can put 1. So this represents towards the uniqueness quantification. Or we can say in this case, there is exactly 1, or we can say there is one and only one value of x in the domain for which the statement is true. Let's take an example. Suppose we have this form. There exists a 1x for which x minus 1 is equal to 0 from the सेट ऑफ रियल नंबर. क्या सिर्फ एक ही वैल्यू है x की फ्रॉम द रियल नंबर सच दैट x minus 1 is equal to 0. So the statement is clearly true because सिर्फ x is equal to 1 के लिए ये statement true है, otherwise false. So yes, only one x exists for which x minus 1 is equal to 0. And if I say that whether there exists only one x such that x square is equal to 4, so this is completely incorrect because we are getting more than one x for which this is true, that is 2 and minus 2. So it means the statement is false. But the main two quantifications are universal and existential.